Hello everyone, and welcome to Control Automation Day 2023. We are proud to deliver our first keynote presentation from Rockwell Automation, sponsored by Mouser Electronics. There are many emerging technologies influencing the world of modern manufacturing. Many of these are collectively grouped into terms like digital transformation, Industry 4.0, and IIoT, which is the theme of this year's Control Automation Day. Today, along with Arvind Rao, the Global Vice President of Industry Solutions, and Dave Vasco, the Senior Director of Advanced Technology, both from Rockwell Automation, we will discuss the evolution and actual practical application of many of these new technologies, including artificial intelligence, digital twins, and even virtual and augmented reality. Well, Arvind, Dave, thank you very much for joining us here for Control Automation Day. I'm really glad that you both are able to lend your time and your expertise to our audience today.
Thank you. Glad to be here.
Yeah, thank you, David. This is good to be here.
Yeah.
So before we get started with our discussions about the IoT topics that we're going to be talking about today, I was wondering if you both could give us just a little bit of your own education and professional background that got you to where you are, both in Rockwell as a company, but also to this point of intersection of where the hardware and industrial technology meet. Arvind, why don't we go ahead and start with your story?
Yeah, no, sounds good. I grew up in India. I'm an engineer by training. Both have a bachelor's and a master's degree in industrial engineering, where I studied things like CAD, CAM, and systems and robotics. I started my career as a plant engineer doing automation projects in plants, helping drive efficiency, throughput, quality, and that's where I grew up. Working in plants, understanding how we made things. Went into operations management. Always wanted to get on the business side of things, and so at one point I stopped working and actually went and did a full-time MBA from the University of Michigan, and then went into marketing and strategy roles. Worked for different companies, and I've been at Rockwell since 2014, and sort of Rockwell has been a great home for me because I love manufacturing, love technology and automation from my earlier parts of my career, and they all come together really well.
I've talked to quite a few people now that you mentioned that the business side and the engineering, with degrees like engineering management and things like that being quite popular. That's
absolutely.
It's great to hear your story. Dave, what about you?
Like Arvind, my background is engineering. So my undergrad is electrical engineering. My graduate work is in computer engineering. I've been with Rockwell in many different roles, development roles, system engineering, R&D, and communications, functional safety, just really a lot of different opportunities here. And I've loved the challenges here. Right now, I'm in an R&D role looking at applied research on how to really leverage that for Rockwell Automation and bring these technologies in and make them mainstream so that people on the floor can use them and we can help to make people more productive. And that's what keeps me awake at night. So that keeps me busy during the day.
Well, we have a lot that we're going to talk about today, a lot of these specific technologies, and diving down into let's start with a couple of specific technologies, particularly artificial intelligence and machine learning. I think most engineers, probably nearly all engineers, have heard of the concept of artificial intelligence and have perhaps used it. Dave, can you give us a brief definition of artificial intelligence and what it means in the context specifically of a manufacturing floor that many of these engineers might be working in these days?
Yeah, I like the fact that you're qualifying it because artificial intelligence means so many things to so many people. You see a lot of hype, you see a lot of misuse of the terms, but practically in the manufacturing space, it really is pattern matching. Looking at patterns, being able to recognize them, and it can really provide a lot of value in the manufacturing space. So for somebody that can leverage experience of an expert and see what the expert did, it provides a lot of benefit. If they can see maybe somebody has done something, they haven't done it for years, and that comes up again, they can see what actually happened last time, how that was addressed. It can make people more productive. So I definitely would encourage people to learn about AI and machine learning. I love the University of Helsinki course, Elements of AI. I think everyone should take that. It's very accessible.
Now, one of the benefits of having a discussion like we have today is that we can look at multiple perspectives. And certainly there's the engineering perspective, being able to define what these roles and what these technologies mean to an engineer. But Arvind, perhaps you could present a counter opinion as well from the business side. How would a company judge, based on that business perspective, whether some solution like the artificial intelligence or a machine learning solution, how would they judge whether that would yield positive results? What are some of those KPIs that might be expected?
Yeah, no, absolutely. And I'm glad we're talking about the business outcome and the value piece, because I think so many times we are so technology focused that we forget that at the end of the day, we're doing this because we want to drive some value to the business. There's an outcome we want to drive, right? So my opinion always is to start with that problem. What is the problem we're trying to solve? Is it the right problem to solve? How much value can we sort of bring back to the organization if we solve that problem? So starting there is really, really important. Otherwise, it's a science project, and like many science projects, the technology might work, but we might have no understanding of what value we actually deliver. So getting to an ROI becomes very difficult. And if you don't have generally in most cases, if you don't have a good ROI, your program or project isn't going anywhere because nobody's going to fund it. And so my point always is start with the problem, understand the problem, quantify the problem. What is it costing your company? Is it reducing revenues? Is it costing more to make a product? Is it resulting in more waste? And you quantify that cost or that impact that it's having for the company. And then you work your way backwards to say, okay, what are the right sets of technologies we want to apply to solve that problem? And what we find in most cases, it's very difficult to go straight to AI or ML because they're all dependent on data. So a lot of times, you might start with simple analytics to simply say, I'm collecting simple information, I'm connecting it to a sensor or a source of data, and I'm just visualizing performance. I have visual analytics, what we call descriptive or diagnostic analytics, which basically tells me how my process is working, how my asset or machine is working. It's not doing any AI or ML or anything at this point. It's just showing you performance. And even with that, you can say, well, machine A is performing better than machine B, so let me go find out what machine A is doing and try to replicate that in machine B. So just getting data and visualizing itself can provide a lot of good information. I think once you're comfortable with that and you've collected enough data, then you can go into the AI ML space to say, can I build predictive models? Dave talked about pattern recognition, pattern matching. So can I put together models that say, hey, this is the best way that this asset should run, and every time it's slightly skewed from that sort of reference point, it's telling the operator or the plant manager to do something, to go fix something. And so it's the human is still involved in making that decision of should I make a set point change or should I make a change, and then finally get to that full closed loop of you've got a good AI or machine learning model that you really trust, and then you let it actually just operate autonomously to close the loop, and the human then can look at much more value-added activities, right? So when you take that kind of journey, you get a return, you get an ROI. So from a business perspective, you've mapped your problem, and then along the way, you measure improvements, and you can prove to whoever is approving budgets that there is a value here, and then you can scale and do that multiple times.
Now, several times there you mentioned quantifying and data, which means this is definitely both the preparation and the analysis are driven by numbers. But I know I've run into a lot of companies where the access to the data is only given to certain people. And so sometimes, especially maybe junior engineers and technicians kind of feel like they're not a part of this process. But Dave, maybe you can answer this. How can having access to that data be a part of an effective job routine for junior engineers and technicians to be a part of the larger decision-making process that helps companies achieve more success?
Yeah, I mean, access to the data is crucial, but I have to caution that normally just having access to existing data isn't enough. And I've been in plants where they give us 10 years of every piece of data they have, and you'll see many sensors are flat. You're not going to have much learning that goes on. So the existing data is a start, But once you get in there, you analyze things, you may find you need to add sensors. You may create simple models that'll cause you to have more of a view of what's happening, and that may have you add additional sensors to that, different types of sensors. And then from that, you're actually able to make a lot of the impact. Having access to the data is critical, but keep in mind you may have to go back and add additional sensors. That is not uncommon at all.
Now, as we look at the two different atmospheres here of the engineering and more of the executive, the decision making, the long term thought process, we certainly see different timelines, because I can speak as an engineer, and maybe many engineers share this same feeling that I really like results and to get started right now. Once I have an idea, I want to get moving with the idea. But more the business side needs to look at a long-term plan to be able to evaluate success. So, Arvind, looking at those two viewpoints, how can those two groups of people work together more effectively to coordinate successful projects?
Yeah, no, that's a great question, and we see it all the time. And my simple answer is they have to be successful in sort of driving, IoT or digital transformation, or whatever you want to call it. You need to have a good strategy and a plan, and you need to have executive level backing to make sure that you're not just doing one project in a few months and then it kind of dies, right? So you have to have a plan and a strategy that articulates, again, back to my original viewpoint of what is the problem, where you almost look at your P&L or your income statement, and you look at what are your biggest revenue drivers, what are your biggest cost drivers, where is your cost, and then you have to apply technology to optimize. Either you get more revenue or you reduce costs. So you have to start there with the business in mind and the value that you can bring to the business, and then think about how you can scale those solutions. So how do you take it from line to line, or line to the plant, or plant to plant across your entire network if you're a medium or a large size manufacturer? So you have to put together a strategy on how you want to go about actually accomplishing the task, how much money you're willing to invest, what the return on investment would look like. And I think once you have that plan, and you know what you're going to go address, then you need qualified, skilled engineers, architects, technicians that really know that OT environment, and they can actually implement those projects. So you kind of need both groups to work together for success. Just doing projects without having a plan isn't going to get you very far. You may do one project with some limited success, but then it's very local success. You're not really having the full value of what you think you can accomplish. So that plan and that strategy will help you go. You'll have to put in some upfront work, but in the long term, it'll help you go faster. So I would say both groups have to work together to be successful.
Now, kind of expanding on that question, another thing that engineers like to see is success. Well, everybody likes to see success. But before the scaling process happens, when a pilot project is chosen and it's a small pilot to begin with, is it all right for projects to fail at that very early small stage? And if so, what can engineers learn from that process to create success for future events?
Sure. I mean, that's part of it. You want to go in there and see if it's going to work or not. What are the limitations? What's the resolution? What are the predictions that can occur? But you can learn from failure, and that's why you do incremental steps. You do improvements. Many times it's not a complete failure. You find there's some success to that. You can find what does work, what doesn't work, and you can build from that. And a lot of this is iterative. It's not a big bang where just it happens across the entire plant. You build on those successes. I think Arvid was talking about the business case. So you have that success, you build upon that, you use that to fund the next one, and the next one, and the next one. So that's part of the process.
Dave, are there any examples of some companies that you've seen that had certain challenges and then they saw the opportunity to present either an AI or an ML, since those two concepts are what we're discussing right now, and then we're able to effectively implement them? And what kind of results did they see from that?
Sure, I'll give you one. So Arvind talks about the business impacts. We were approached by a customer of ours, very large coffee manufacturer, and they had a problem. They had these dryers for coffee, and they had hundreds of these lines. And they found that at any given time, 40% of the lines are down for cleaning. Because if you run a line too long, it'll get fouled and all the coffee will be ruined. So they had a tendency to take them offline early. And that meant that if you have hundreds of lines, you have 100 dryers that are sitting there doing no constructive work. That's very expensive. So we actually tried to figure out what's causing that and if there's any differences. We put some machine learning on that directly right at the dryers themselves. We found out that the amount of fouling that occurred was very different for caffeinated coffee and for for decaffeinated coffee. And then from that, we could learn the contribution each had, then monitor what's happening, and then predict the perfect time to bring one of those dryers down for cleaning. So it made a huge outcome for them as far as their machines were now operating at the optimal rate. And we did all that work locally at those machines. We then pushed all the results up to the enterprise. And at the enterprise, they can look and see who was following the policies and procedures, who maybe needed a little more training, maybe there's just some systemic problems with the equipment itself that needed repaired, but allowed us to look across the enterprise. So solving it quickly right away at the machines themselves, and then pushing that data up to the enterprise, and that was a big game changer for that company.
Now, we've discussed AI and machine learning concepts, but there's another technology that has gotten a lot of attention, especially recently, that I'd like to discuss just a little bit, and that's this concept of digital twin technologies. And now I know a lot of companies use, especially IT companies, they use this term scalable. We've even used it in this conversation, starting at a small scale and then allowing the project to grow once it sees success. But Arvind, perhaps you can explain a little bit more about how that concept of scaling applies to this idea of digital twin, and maybe even define digital twin a little bit for our audience that may not be familiar with it. But how can you apply such a digital creation model at a small scale and then grow that adoption? Or is that even possible to scale in a digital twin environment?
Yeah, sure. I mean, I'll start with a very simplistic definition, right? A digital twin is simply it's a digital replica of what you see in the physical world, right? And there's many types of digital twins. You can have digital twins that are based on data. So you have data models that are describing a certain asset or a certain process. You can have digital twins that are, if you look at sort of 3D drawings, or 2D drawings, you can have twins that are, built out of CAD systems. You can have data-based digital twins. You can have a combination of the two to create a much more, I would say, a realistic or more accurate digital twin. Many companies even use first principles equations to describe a process or an application. That's a digital twin. So at its simplistic, it's a replica of what you see in the physical world. And from an application perspective, what it's really driving value is that in the virtual world, you can make mistakes, and mistakes are not as expensive if you actually made them in the real physical world. So anytime companies want to look at how systems interact, have I set up my line correctly? Is all my code, my control code, has it been written correctly? My integration between the conveyor line and the robot, is the robot going to hit the conveyor line? Is all that sequencing done properly? So all of those things can be simulated. You can simulate an entire plant. You can simulate how a warehouse works. You can test for different what-if conditions. Will I meet my throughput rate? Is my quality going to be where I want it? Am I going to have incidents from a safety perspective? You can simulate all of that in the digital twin using digital twins. So really, it's driving time to market. It's driving reduction in cost, and it's really driving safety, and it's making the workplace a lot safer. So those are some of the benefits. To your question purely on scale, I think digital twin technologies can be used by anybody. I don't think it's dependent on the size. I would say a few years ago, the amount of compute power and the dedicated sort of compute and the workstations and all the technology, the software that you had to buy to create digital twins and run digital twins was expensive. But I think those days are gone. We have now pay-as-you-go as a service models, which really benefits small and medium-sized manufacturers, that they can, sit pretty much on their browser, log in, create twins, run twins, do their simulations, what if analysis, and then just pay for that chunk of time that they were using the resources and the technology, and then leave. So it's, you've got these pay-as-you-go software as a service models that we are seeing all over the place that really help provide that value to customers. So I don't think it matters anymore whether you're small, medium, or large. You can all benefit from the value of the digital twin.
So this digital twin concept, probably for many people, especially in the engineering, more hardware related realm, that sounds kind of buzzword. It sounds like a buzzword in this IoT world. But Dave, more from a hardware level, when I think of twin, I think of two things. There's the digital environment that Arvind has described, but what is required, or is it even required, to include the twin hardware components, or is that something that can be added to a process later? In other words, do you need to have both sides of this twin environment in order to capitalize on the digital twin technology?
Well, the twin is it's a living replica. So you may have a plant, you may have a machine, you may have a device, and then you have a virtual replica of that, a living replica of that. So it really allows you to have visibility into what that device can do. And Arvind mentioned like first principles. If you could build your twin based upon first principles, you could actually talk about and understand things that you've never tried before. Is this device capable of this? You could make judgments as far as when might this device fail or break, and those are really crucial. So really, you have both parts. You have that virtual part that you're able to analyze and provide sophisticated tools on, and then you have that real product, a real thing that you're twinning, and having that combination of the two gives you so much flexibility to be able to try things, and it's a very, very powerful tool. We've been actually doing twins for 25 plus years, long before the term was even coined. What's changed, which Arvind mentioned, was it was very, very difficult and expensive for all those tools. And now that processing power is available, the communication is available, the sensing is available, it's very easy to apply those tools in the manufacturing today.
I have to admit, I just recently was having a conversation with someone that really opened my eyes to the process of data collection, because to me as an engineer, data collection meant sensors. So I would think of sensors connected to a system to gain temperature data, et cetera. But having this digital twin concept meant that now data can be collected about a process 100% virtually. And just the concept of that makes sense to me now, but is quite surprising to think about. So
Yeah,
I have a question for...
Oh, I was going to say, it's not just sensors too. I mean, it's like we have drives, and you think about a drive has to understand the voltage there, that's currents there. It can give you decisions about power, and you wouldn't think of a drive as a sensor, but it is within a manufacturing environment. It could be a viable sensing tool out there.
Now, question for Arvind. Are there any examples that you've seen? You mentioned that it used to be big companies and now it becomes more accessible. Are there any examples of some equipment or processes that you can point to that have seen more flexible development time or better optimization because of this new digital twin environment that's possible?
No, absolutely. We work with many original equipment manufacturers, so machine builders that use our hardware, and now we're starting to see many of them leverage our software and create digital twins of their equipment. And so a simple thing that is that they can perform factory acceptance testing in a virtual world. So they're cutting out basically the time it takes to ship the machine to the plant, then do physical acceptance testing, and then find out that there were problems and having to either reprogram something or adjust a certain fixture and all those things. And that is lost production time because that machine can now be in production, running, making product. And so a lot of our machine builder customers are starting to look at how they can use digital twins of their equipment when they build them and they can simulate their control code, all the interactions of the various mechanical systems with electronic systems, sensors, software, all those pieces together in an environment, and basically do virtual acceptance testing. And now with the power of the cloud and things like that, you can collaborate. So you can have an engineer that's from the machine builder with the engineer from an end user or a plant operator that's going to be running the machine in the future, all work in a cloud environment and really do that acceptance testing, do training on the machine, understand the control code. So the cloud really opens up that collaboration paradigm that didn't exist before, because you had to sit in a plant with a single desktop computer and different people trying to work on it. But in a cloud environment where all the digital twin technologies are available as a service, you can have engineers from multiple organizations and functions working together to make sure that the machine, before it ships, meets the end user requirements and the functional requirements, right? So that's a really good example of even smaller companies starting to use digital twins. But as you get more complex, we're seeing end users simulate, for example, an entire warehouse, right? And again, it's like, what if my production goes up 20%? What if my volume goes up 5%? Do I have enough forklifts? Do I have enough operators? Like, you can run all. So you're seeing these twins get more complex, and there's systems within systems, right? Systems of systems. So you're starting to simulate at a higher level. And so that complexity is increasing, but I think the compute power we have is quite limitless today. So we are able to do much more advanced digital twins. And the last thing I want to say is that, we talk a lot about technology, but we forget the human aspect of all of this. This entire digital twin and augmented reality has a huge human aspect to it. And what do I mean by that is that you're starting to see, experienced workers leaving the workforce, retiring, and the new workforce that's coming in doesn't have that 30, 40 years of running a machine or working in a plant. And so we can capture a lot of that knowledge in work instructions and really digital work instructions using some of this technology, and applied with the digital twin. Really, it becomes a training tool as we bring in newer folks into the workforce. We saw this very useful during the pandemic, when a company that was making a product A suddenly had to switch to make sanitizers, for example, right? They were making a liquid-based product, but they had to go from a beverage to a sanitizer, and that's a completely different process. And so, how do you train overnight all these people? And we're starting to use augmented reality. Companies that wanted to add a third shift to ventilator or respirator production, because those were highly in demand. How do you train that third shift workforce, right? So you're starting to use digital twin and augmented reality and things like that to really make humans more capable, right? So that's a key aspect as well.
Yeah, I'd like to come back to that augmented and mixed reality subject here in just a couple of minutes. That concept of training, though, that one really stands out as a cost to companies that is inherent anytime a new employee is either onboarded or moves to a different position or even a different shift. That's a very interesting thing to think about, the ability to accelerate that onboarding period, which can be very expensive for companies in some cases.
Yeah, absolutely.
Yeah, absolutely. I think if you think about how humans learn, right? I mean, we generally, in the past, we would train somebody and we just expect them to retain that knowledge, right? I think a lot of these technologies, these are available at your fingertips, right? So when you run into a problem, that's where you really want the training. So how can you quickly access information in a digital format so that, you almost, like, we all love those YouTube videos on, hey, how do I, so products that come with manuals. I don't read a manual anymore. I'm always on YouTube going, how do I assemble this, or how do I install this? So I'm not reading the manual anymore. So it's the same concept. Why should we expect the new workforce to depend on paper-based work instructions? And you get training when you first start, and then you don't get trained again, and then you're expected to remember. I think that's just difficult to do. So how do you make training available when it's needed at your fingertips? Right?
So that addresses the human element of it. But Dave, maybe you can answer this question. As we look at where the digital twin is able to be implemented in different parts of a process, we know that when equipment is needing to be changed for a purpose, like switching from beverage to hand sanitizer, but there's also the time in which the equipment is first being installed, or even when the equipment is first being designed. Is the digital twin a useful tool in each of these stages as well?
Yeah, absolutely. So a digital twin can be applied in the design phase, it can be applied in the commissioning phase, it can be applied in the operational phase, or it can be applied in the maintenance phase. And the best practice really is to start in the beginning, design, try the possibilities, debug it, and then take that twin and that model you developed and leverage that to reduce commissioning time to an absolute minimum. Commissioning time, like Arvin has talked about, really is extremely expensive. You're not producing anything in that factory. If you could reduce that to a bare minimum and hit the ground at a productive volume from the start, that makes a big difference. Then while you're there, use that model that you built during that design phase operationally. You're trying to optimize it. Maybe you're trying to reduce the energy uses, make it more sustainable. All those things can be done. And as different things occur and you're changing products, use that digital twin model to understand the true capability and flexibility that you have in that plant. And then while you're doing that, use that model, hopefully maybe a first principle model, a WARE model that occurs to help you predict maintenance. What's your actual maintenance based upon the usage? When are you really going to need to replace filters or replace parts or do maintenance on those items based upon the actual usage? So the best practice is really taking that digital twin, using it across all phases of the automation cycle, and that's where you get the most benefit from it.
Now, compared to an application of AI or machine learning, which could be just a small piece to begin with, this sounds like a little bit more of a significant project. So, Arvind, what might you recommend for a company that's thinking about taking a step to invest in a digital twin? What kind of resources, computational resources, staff from both the IT and the engineering side, the expertise and skills, what kind of resources are needed there for somebody to even think that this might be a suitable application for them?
Yeah, I think, like I said before, it's really not a resource question anymore, right? I would say that, the best way to start is to work with a partner or a supplier or, or a vendor that you're comfortable with, and go with sort of software as a service model, which gives you the most flexibility at the lowest cost, so that you can use the right types of resources that make sense for you and what type of use case you're trying to solve. So I don't know if it's a huge burden on IT anymore, or hey, I got to set up this huge server infrastructure and all these nodes, and I got to be able to manage all of them and make sure I have enough server horsepower, and I got to put capex investments to scale those up as I start doing more projects. I don't think that's really the problem anymore. I think the investments really need to come in terms of, like, do I have the skilled engineers that can create the digital twins? Can I people that understand sort of CAD systems, people that understand data models, AI learning models? How do I create the right digital twin concept? So the right skilled engineering and technical folks, like, make sure that you have those in your company. That would be a really good place to start with. And then I think the second part is, you can't do it isolated, right? There has to be a strategy of how you want to start and what business value you want to provide. So I go back to where I started this whole discussion, is that digital twins are cool, right? It's cool technology. Everybody loves to see 3D parts kind of spinning around, and it makes everybody smile, right? But the point is, why are you doing it? Like, what is the benefit? What is the business outcome that you're trying to achieve, right? And how are you delivering that value to your end customer, right? So if you're a machine manufacturer, are you helping your end customer start up faster? Are you helping you're cutting lead times for your machine so that they get to your customer faster, so they can start producing? So always have that end customer in mind in terms of, like, what value you can deliver for them as you look at creating digital twins. So don't do it just because it's cool technology. Make sure you have a good business case behind it.
Like you said, you started with that and keep coming back to having a reason and a purpose. And that
Yep.
purpose can't just be because it looks cool.
Right.
Although it's true, it does.
Mm-hmm.
Keynote speakers and live sessions for Control Automation Day are brought to you by Mouser Electronics. As your design fulfillment distributor, Mouser is your authorized source for millions of components from thousands of leading brands. Come discover, design, develop. Now, earlier we talked a little bit about the idea of virtual reality, and I guess that kind of includes augmented reality and the mixed reality. I think usually they use XR as kind of the acronym for this mixed reality kind of environment. And originally, years ago, it was only really seen by gaming companies, like video game companies that wanted to create a more immersive experience. But Dave, maybe you can answer this question. What kind of purpose do those kind of technologies serve, both the virtual and augmented reality, for the industrial controls engineer type of role?
Yeah, sure, sure. So you're seeing the technologies being applied. So virtual, you have a complete virtual environment. And we are seeing that being used for like developing a model of a line before it's built, helping to build that digital twin and try it out and getting that immersive experience there. We've seen it being used for training people, particularly there may be dangerous jobs. I've seen jobs like um, welding, or people are trying to do welding up in rafters, and they do virtualization of that and use VR to actually train them. But you could go through those learning experiences in VR. You could push those experiences out to lots of people. You could try things that might break your equipment, but in a virtual environment, they don't do that. So you really can get a lot of feel, just like we do with our fighter pilots, our airline pilots, to give them many scenarios to understand that they're trained before they ever get out there. So that virtual reality really provides that. Now, the augmented reality provides a little different view. You're able to see what you see normally, and then you have augmented information on that. And that provides the opportunity to do things like just in time training. We talked about training instead of going through the books and learning something just in case. You could do just in time training. Somebody walks up to a machine, be able to identify that machine, be able to push down information, instructions, maybe even videos on how to repair that machine. I think Arvin used the YouTube example, but a little video. So you're getting the training just in time. And then even have an expert sitting there and watching what's happening along with you. And that expert could be drawing things on that 3D space. So you're actually seeing it right where it is in the real environment. And the real environment is augmented with that virtual information told precisely what to do. And that's really important. I mean, we saw with the pandemic, even just you think about it, flying somebody out to a plant to fix something when you could just throw a headset on, send somebody out, have a trained expert, worldwide expert, sit down and help you. Think about how powerful that is. And particularly as we struggle with training our workforce faster, getting experts out there, these are tools that can make businesses productive today.
You mentioned the crisis of the pandemic, and I think not only did just your illustration of getting somebody virtually on site faster, um, that's probably an ultimate goal of any field service organization, regardless of the pandemic. But that certainly accelerated this trend of working from home. Are those kind of technologies able to be employed by some companies that are struggling to find people who are willing to come in to work on site every day? Can some of these mixed reality technologies enable that work from home, remote working more easily?
Yeah, absolutely. So, and you think about it, it even changes the requirements. So you could have somebody that maybe has some mobility issues, but they could be the worldwide expert on fixing equipment, and they don't need to go out and travel all across the world. So that this really allows experts to be available on demand to meet those needs. Um, and you could allow people to wear a headset, and they're trained on all the safety procedures for the factory. They may be a technician in the factory, but they then can have the expertise of people outside. So it helps businesses, small, medium, and large, really to meet those needs that we have to be able to derive solutions for the future.
Now, all this talk about technology that we've done so far, I think going back even a few more years, many more years, to when robots started appearing on the scene. we had this claim, and I still hear this claim quite often, that automation is going to be taking away all of the jobs that people had. Arvind, can you address that question, and maybe how has that narrative changed between the early days of automation and especially robotics compared to what we're seeing in reality now that they're becoming more widespread in adoption?
Yeah, I mean, overall, I think we've got enough studies and facts to show how automation has helped, um, you know, just the planet. Um, it's helped the planet in producing things using less resources, producing things with less, energy and water that's needed, uh, producing food, uh, drugs, like medicines, etc., that are sort of lifelines of like the things that humanity needs to survive, and at productivity levels that have kept up to feed a expanding population. Right. So I think the benefits of automation have been well researched and documented in terms of what it can do. I think as we look at what's happening now and even in the future, there are a lot of elements. Sometimes when you have an operator standing in front of a machine, they've got 15, 18, 20 different variables that they can change and try to figure out what's the most optimal way to run the process. But I think the human brain can maybe look at two or three variables and make adjustments in real time. And that's where really automation plays, right? Automation can look at hundreds of variables if needed in real time and make small changes to optimize that process and keep it under control, right? So we're starting to see, and we've been doing this for many years, so it's not anything new for us, but we're starting to see customers adopt kind of that self-learning, self-aware, closing the loop in real time. So really, automation and autonomy now are bringing another next layer of sort of productivity and efficiency that we haven't seen before, and it's allowing humans to do other value-added activity, right? Instead of standing and staring at dials and waiting to change something, now you can have that human look at, hey, what's coming next, and how do I get ready for it? How do I go do some training here? So it's sort of allowing humans to expand what they can do, as opposed to like standing and trying to do routine tasks that they've been doing. So it's helping upskill humans. It's helping them add more value to work. Dave mentioned there are very dangerous environments where robots can work now, where you don't need to have humans, right? So it's absolutely adding from just a human safety perspective, tremendous amounts of value. So at least we don't see it that way. That automation is taking jobs away. I think it's making the world more productive. It's making humans more productive, and it's only going to increase the value that it's going to bring to society as a whole.
Can I just build on that? I think, Arvind, I think those are some great points. But you think about it. You think about a company that is optimizing what they're doing. They're productive. They are growing, and they're the most efficient at that particular task. They're going to grow. And when they grow, they're going to hire people. If you look at a company that isn't automating, isn't increasing their productivity, they're going to shrink in size and they're going to lose people. And it's as simple as that. And if you look at the data and you look at the countries that have adopted automation and robotics, their employment is going up in those fields in manufacturing. If you look at the companies that are countries that are less likely to do that, their workforces have gone down in those fields. So the data really does bear that out.
Yeah, great point, Dave. Thank you.
So it's not just a matter of saying to the claim that the automation is taking jobs away, and not only would you say that that's not true, but rather it's the exact opposite. The automation enables the growth of more jobs, and not just jobs in general, but jobs that add to people's creative skills and really are better for people. At least I've always been a believer that when you engage more with what you're doing and you're learning and you're growing and you're taking advantage of why humans are so good at being in charge of technology, those are the really satisfying jobs.
Yeah,
Absolutely.
It builds jobs, and it builds better jobs, and they really are exciting.
Now, Dave, I know I keep turning to you for examples, but can you, since our engineers love to hear about about examples of where some of these technologies are being implemented. Can you explain to us any case studies that you've encountered with companies using XR technologies to realize some actual tangible benefits?
So, I mean, we use it every day, the XR technology, particularly virtualization, in products like Emulate 3D, where you're able to actually go in there and create a line and do optimizations. We've had beverage applications where we've gone in there to design the entire line virtually and being able to optimize it. And we find pinch points, we find places where we actually slow down parts of the line in order to speed up production and to optimize workflow. That's very common. We've done that. In even the technologies like the AR headsets, we've used those for actually doing inspections in our plant. Instead of sending somebody down to one of our manufacturing plants, send a headset down there or one of the VR XR sets and have them walk through. We could do the inspection remotely and verify that everything was done correctly with somebody that's trained in the safety procedures for that plant. And that's a big benefit, that being able to do that without having to have that plane flight, that delay, all those things. So yeah, those technologies are being adopted today. They're becoming much more cost effective, and they're having a difference.
I know just in the last few years, I've gotten a chance to use a virtual welding trainer made by Lincoln Electric, and a fully immersive experience that according to the research data says that it trains people just as effectively as physical welding, with only a fraction of the amount of consumable cost. And there was another local company that I was able to conduct some safety training or go through some safety training by using a VR headset as well. So some very, very interesting technology developments.
Absolutely. We work with a university in Cleveland, Case Western Reserve, and their gross anatomy, they've actually used AR training for that. And what struck me is talking to some of the students, they said that that AR model of a person, that was actually more real. They understood more about how the different systems work than if they were actually in a dissection lab. And it was a surprise, but it actually makes sense.
I did get to see one of those tables at a community college in Colorado, I believe, and I was surprised that I would not do well in the medical field. I'm not designed for medical procedures, but I was able to see and understand and interact with the virtual model completely fine. So I think that really changed the way that I saw training in this virtual environment. It's not just a physical, but it also creates some psychological benefits as well, I think, for training in certain environments. Although I will never
Absolutely.
sign up for a medical degree to become a doctor. Now, one of the key points that we've been focusing on through this discussion is how these kind of technologies aid in flexibility. So I do want to talk about that just a little bit more in detail, because this flexibility, especially, I think there's so many examples during the pandemic of just here recently, we talked about the beverage to hand sanitizer application, being able to change a process and operation overnight to respond to demand. So for a question here for Arvind, is it reasonable to expect even small companies to be able to compete with leaders in terms of the responses to kind of the global environment, supply and demand, or are they inevitably just going to be pushed aside by the companies that are big enough to be able to employ engineers and make these changes whenever they want? Can these companies compete using these technologies?
Yeah, I mean, I would almost flip it a little bit and say they can make it a strategic advantage, in terms of how they operate with flexibility, with automation investments, with the right people investments. You can absolutely attain that flexibility. For example, you think about, as consumers today, we want different lot sizes. We want things that are designed specifically for us. So almost getting to a batch size of one, right? And so that, today technology has made that very possible. And it's not that you would be investing way more than what you would in a sort of a normal automation line. So for example, you can modernize. You can look at, from the cloud, you can say, okay, I want to modernize, or push code down to all my devices, my controllers, my lines, to modernize. So there's a lot of flexibility there, and you can say, I want to send recipes, I want to send work instructions down across my lines to achieve all of that, right? And so that kind of flexibility to be able to change just even conveyor lines and sizes and things like that with a click of a few buttons, because it's all software defined, has made that possible now for any size company to adopt, right? So I think I would say that these companies can make it more of a strategic advantage than being concerned about it being a competitive threat, that they should really start leveraging the technology to differentiate themselves. And flexibility can be a great differentiator.
Over the last couple of years, it seems like so much technology has created the need for flexibility. And I suppose the pandemic, of course, being such a huge event, is one main reason. But Dave, can you speak to any other things that may have changed over the past couple of years, and maybe even projections for the next few years, things that are going to force companies to be faster to change than they ever have before?
Sure. So, I mean, one of the big trends that we see occurring is people may call it reshoring or shoring or localization, but we're seeing a lot of manufacturing being duplicated locally so that we reduce the supply chain, we increase the resiliency there. And you're going to see a lot of that. Having the ability to be able to use local goods and services to meet those needs, and having the flexibility to adopt those. And then also think about when parts aren't available, when there's resiliency or supply chain challenges, could you still make something? And we've seen that in plants today with digital twins. Digital twins can tell you if you have the capability to make something. You may have something broke in the plant, but you could maybe still make 30% of your products or 70% of your products, whatever it is. You may be missing pieces, but you still can make other products. And having that understanding of what your true capability is incredibly powerful. And it gives you the ability to pivot to new areas or produce things that would have let the plant otherwise idle.
With all this talk about all these new technologies, I guess it's obvious that the workforce is going to be changing, or has been changing, and that will
Mhm.
continue to happen. If you were to be looking for a certain set of skills or a certain profile of individual to champion these kind of digital technologies, Arvin, maybe you can speak to that. What kind of skills should a manager, a director, or even if it's a small company, the CEO, what kind of skills should they be looking for in these next couple of months and years to make sure that they're setting themselves up for success?
Sure, great question. So continuous learners, right? People that are ability to quickly learn new things. So I think continuous learning is a skill and a need, and I think people that can do that well will succeed in the near and the distant future. I think the second one is the ability to absorb change. I mean, the pandemic showed us how we need to change and pivot. And I think pandemic or no pandemic, the ability to change quickly and adopt and be able to absorb new things is going to be critical as well. The other thing is, from a mindset perspective, people that can challenge assumptions, right? That we've always done it a certain way, and continuously ask yourself, is that still applicable? Are my assumptions valid? Should I look at something new? So people that can constantly challenge sort of the status quo and challenge assumptions that we've held as correct for many years, right? Many of those assumptions now are not valid, right? We can talk with each other completely through the internet. I don't have to be anywhere, right? I don't have to go anywhere. Those a lot of assumptions that have have been tested and proven wrong, and shown good results. So I think somebody that can continuously challenge themselves, challenge the assumptions they have, and then collaboratively work with other people to challenge the assumptions that the others might have, to bring collectively to strong change management. I think those are all critical skills. I think it's not that technology is becoming easier and easier to adopt. So it's not that you need extremely technical people all the time, but you need people that can look at something new and say, I think I can figure this out, adopt it, test it out, and then go use it, right? So that kind of continuous learning and change management is going to be critical.
Thank you. And thank you both so much for this awesome discussion. We've covered a lot of different technologies and a lot of great insights. And before we go, I have another more informal question for you. And this is one that I love to ask because we have a lot of young engineers, either just beginning a career or students. So if you could go back and tell yourself one thing during college that would help you, knowing now what you know, what would that one thing be that you would tell yourself? So Dave, why don't we start with yours?
Yeah, sure. So I mean, looking back, going through all the engineering classes, I always wondered, am I ever going to use this? And and it just seemed like there's so much we had to learn, and I was surprised. I didn't use it day one, but within 10 years of an engineering career, I think I touched every single subject I ever learned, and different problems would emerge, and you had those skills. So, just be patient, suck it all in, learn. Don't be afraid. You're going to make some mistakes along the way, but definitely treasure it and learn everything you can because you probably will use it in the actual job at some point.
Yeah.
Thank you.
I mean, I'll just add to Dave's comment is that I think we need an education system that is more focused on solving problems than just teaching sort of technical, information. And so what I would say is that the one thing that I would change if I had to go back is that I would question every time I learned something, I would be like, how can I apply this and what problem can it solve? Right. And that's a challenge to even our education system and our teachers. And every time I talk to my kid and they talk about, oh, I've learned something new in math, I'm like, do you know how this would get used in the real world? And so I sit down and have a conversation with them. But I think that's one thing that we have to figure out is that we want problem solvers, in our future generation. Right. So I think that's one thing that I would focus on.
Thank you. Yes, those are great pieces of advice. Again, thank you both so much for your time here today. This has been a great discussion. I've learned a lot. These are a lot of new technologies that I have only a limited amount of exposure to, so I love learning more about them in hopes of being able to figure out ways that I can not only apply them for my own challenges, but also be able to help bring some more understanding to the engineers that use our technical resources and use our site. So thank you again very much for your time and your experience that you've shared with us today.
Absolutely. Pleasure being here.
Yeah. Thank you, David.
Thank you. And thank you to our audience for joining us today for this keynote sponsored by Mouser Electronics. Once again, our sincerest thanks to Rockwell Automation and to both Arvind Rao and to Dave Vasco for sharing their time and experience with us. We hope that you will visit the virtual vendor booths and watch the other keynotes and live session events, all of which will be available on demand after today so that you can share the experience with anyone who may have been unable to join us live. Thanks again for joining us for this Control Automation Day 2023 presentation, and we'll look forward to seeing you again sometime soon.